Let's swim to the moon.
This experiment, which can prove that the moon does not reflect sunlight, can be carried out by anyone and requires very little equipment. All you need is a pair of glasses or a polarized lens. What is a polarized lens? Polarized lenses are laminated with tiny vertical stripes that only allow vertically angled light to enter the wearer's eyes. Glare is eliminated because the horizontal light waves cannot bypass the vertical filter. Sunglasses and camera lenses are often polarized to reduce glare from surfaces, such as light reflecting off a lake or the bonnet of a car. How do polarized lenses work? When light bounces off of a surface, its waves tend to be strongest usually horizontally, vertically, or diagonally. This is called polarization. Like Venetian blinds, the horizontal rows of iodine crystals contained within the polarized lens block out horizontal polarized light waves, letting only non-polarized vertical light waves reach the eye. Polarization blocks as much as 50% of the light passing through a lens. The person looking through the lens can still see clearly in most cases, but it reduces the brightness and glare of light. So if I look at the surface of a lake with polarized lenses, I can see through the water. The light waves reflecting off the water's surface are mainly reflected horizontally, so they are blocked by the polarized lenses. This makes it possible to see clearly below the surface of the water, when the water is clean and transparent, of course. Now if I look directly at the sun with the naked eye or with polarized lenses, I wouldn't see any difference at all, apart from the attenuation caused by polarization, which blocks horizontally reflected waves. According to the official NASA conception, if I look at the full moon, I see the reflected light of the sun, or in other circumstances, the reflected light of the Earth's oceans. So logically, if I look at the full moon with polarized lenses, I should be able to distinguish the surface more clearly. This is because polarized lenses will cut off horizontally reflected light waves. I should find myself in the same situation as when I look at the surface of water, snow, or wet road. Test 12. No, I find myself in the same situation as when I look at the sun. This means that the light coming from the moon is not a reflection of a light wave, but rather, like the sun, from a direct source of light. The moon therefore has its own light. I asked an optician and he confirmed the technical points, but unfortunately he didn't want to believe that the moon has its own light. I also asked ChatGPT just for fun. He told me it wasn't possible because the moon's surface is rough. I replied that the surface of an asphalt road is also rough. This doesn't prevent polarized lenses from doing their job. He then told me that no, the moon has a dusty surface which doesn't allow light to be reflected horizontally. I dropped the matter, and what's more, with distance, if this were realistic, the moon's surface would appear smooth. It just doesn't make sense. If anyone can prove that what I present here is false, please comment. And of course with proof. And proof that everyone can verify.